In this video, we are going to discuss how SEAPATH is dealing with PTP. PTP, so Precision Time Protocol, a lot more precise than NTP, and probably what you will have to use in the environments where you will need SEAPATH to run critical low latency applications. In SEAPATH, the first step to configure a PTP, of course, is to have a PTP network and some boundary clocks or transparent clock in the network. On the hypervisors that will need PTP, the only two variables that you need in the inventories are the interface we are going to receive PTP on and the VLAN ID, the optional VLAN ID in case PTP is only broadcast on a specific VLAN. If you don't use this variable, it will use the interface as an access port with no VLAN tagging. Those are basically the only two interesting variables. It is to be understood that if you don't use PTP, then the failback will be on NTP, which is somewhere else in the playbook. You can set two NTP servers. In case there is no PTP configuration, then the primary will be the primary and the secondary will be the secondary in the configuration. In case you set PTP configuration, then both those servers will be considered as secondary to PTP. PTP will be the primary system to be used for time synchronization. Let's see how it works in practice. In practice, we are gonna set, so in my network, PTP is running on this network, on this interface with no VLAN tagging. So I'm only gonna set this interface and no setting the VLAN tagging. And on the NTP side, where I set it, okay, I'll still configure two NTP servers, which, as I said, will be secondary to PTP and will only be a fallback mechanism. Once you've said this, all PTP is dealt with the network playbook. So you run the network playbook, and if you look in details at what's going on, you will see somewhere that it's configuring time master. So the way we are using and configuring PTP in SEAPATH is by relying on the time master service. There it is, time master. And time master will deal with running specific PTP servers, daemons like PTP4L or Crony or PHC to sys, all the things that you need to do PTP. So it's been configuring. So we can look at time master on the server. It's running. We can also see the logs. We can see that time master has run basic. We'll look at the configuration, but has run a PTP4L, which is the daemon used for actual PTP synchronization on the specified interface. Then Crony to do the regulation, and PHC to sys, which is the daemon used to synchronize the physical hardware clock that PTP is exposing onto the system clock. If we have a look at the generated configuration file, we can see that we have a PTP domain on the specified interface, and we also have somewhere up, where do I see it? Yeah, we here on the Crony configuration, we also have the NTP servers, which are not once again used by default, but which are still there just in case. So if you want to check everything is working fine, Crony C sources is the way to go, and will show you that all the information you need to see on PTP, which is running fine. It's the default, hence the star. We have delays which are very, very small, 30 nanoseconds. So it's pretty nice synchronization. As you can see, NTP, which is the fallback, is 1,000 times more, or should I say 1,000 times less precision. Yeah, so that's for PTP in the host. While we are here, let's discuss how we recommend to synchronize the guests. So basically, once your hosts are synchronized, what we recommend for the guest is not to use PTP in the guest, which by default, which of course would not even be compatible with SRIOV. We can't do hardware timestamping on SRIOV. So what we recommend is to use ptpkvm, which is a kernel module relying on virtualization hypercalls to synchronize the guests with the host. The way we do that is to create a PHC using the ptpkvm daemon. So there should be in the module files, well, I don't even have to set it. Yeah, here I set the loading of the ptpkvm kernel module. So if you go to LSMod, you should see it. And this kernel module will create a PTP hardware clock, and this PTP hardware clock is going to be used by Crony. So let me see here. So we create a PTP conf file in Crony and tell Crony to use this dev.det/ptp0 device has a physical hardware clock. And once again, if you want to check that everything is running smoothly, just run cronc sources, and we can see that our system is synchronized to the PHC with, once again, very small latencies. So to us, it's the best way to synchronize your guests. They are synchronized on the host, which itself is synchronized using PTP. All in all, the latencies are very nice. I hope this was instructive and that it showed how SEAPATH is dealing with time synchronization.